The universe is vast. It stretches beyond our imagination, an endless expanse of stars, planets, and galaxies. When we gaze up at the night sky, we are looking at a tiny fraction of what exists. We look up at the night sky and see stars, planets, and galaxies. These celestial bodies are the visible parts of the universe, the ones that emit or reflect light, allowing us to observe them with our eyes and telescopes. This is what we know, this is what we can see, but our understanding of the universe is limited to these visible objects. There is so much more out there that remains hidden from our view, but there is more, much more. Beyond the stars and galaxies there exists a vast, unseen world that plays a crucial role in the cosmos. Something lurks in the shadows, something we cannot see, yet it holds the universe together. This mysterious substance is known as dark matter. We call it dark matter. Unlike the stars and planets, dark matter does not emit, absorb, or reflect light. It is completely invisible to us. Dark matter is a mystery. It doesn't emit light. It doesn't reflect light. It doesn't interact with electromagnetic forces, making it undetectable by conventional means. We can't see it with our telescopes, yet we know it's there. Scientists have inferred its existence through its gravitational effects on visible matter. How? Because of its gravity. Dark matter exerts a gravitational pull on the objects we can see, influencing their movements and the structure of the universe. Dark matter's gravity is the invisible hand guiding the cosmos. It shapes galaxies, clusters them together, and affects the way they move and interact. Imagine a ghostly dance floor. You can't see the dancers, but you see the curtains move. You see the floorboards tremble. That is dark matter. You see the floorboards tremble. That is dark matter. An invisible force that betrays its presence by its effects on the visible universe. An invisible force that betrays its presence by its effects on the visible universe. Through phenomena like gravitational lensing, where light from distant stars is bent by dark matter's gravity, we catch glimpses of its influence. This is just the beginning. The story of dark matter is a story of discovery. Scientists around the world are working tirelessly to understand this enigmatic substance, a story of the unknown. Each discovery brings us closer to unraveling the mysteries of the universe, revealing the hidden forces that shape our reality. It is a story that is still being written. As we continue to explore the cosmos, we uncover more about the unseen, the unknown, and the fundamental nature of our universe. The evidence for dark matter is compelling. It's a mysterious substance that doesn't emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. Despite its elusive nature, dark matter is believed to make up about 27% of the universe's mass energy content. It's written across the cosmos. The very fabric of the universe is influenced by this unseen force, shaping the structure and evolution of galaxies and clusters of galaxies. One clue lies in how galaxies spin. Observations show that the outer regions of galaxies rotate at speeds that cannot be explained by the gravitational pull of visible matter alone. Galaxies are vast collections of stars, gas, and dust, all held together by gravity. The visible matter, however, is not enough to account for the observed rotational speeds. If only visible matter existed, stars farther from a galaxy's center would orbit slower. The gravitational pull would weaken with distance, much like how planets in our solar system orbit the sun. Think of a merry-go-round. The horses on the outer edge travel faster. This is due to the centripetal force acting on them, which is similar to the gravitational forces in a galaxy. But galaxies don't behave this way. Stars on the outskirts orbit just as fast as those closer to the center. This anomaly suggests the presence of additional unseen mass. This tells us something is wrong. Something unseen is providing extra gravity. This unseen mass is what we call dark matter, and it exerts a gravitational pull that affects the motion of stars and galaxies. This something is dark matter. It doesn't interact with electromagnetic forces, which is why it doesn't emit light, making it invisible to our telescopes. Another clue comes from gravitational lensing. This phenomenon occurs when a massive object like a galaxy or a cluster of galaxies bends the light from objects behind it. Imagine looking at a distant star through a wine glass. The glass bends the light, distorting the star's image. Similarly, massive objects in space bend light, creating distorted and magnified images of background objects. Massive objects like galaxies do the same thing. They act like cosmic lenses, warping the fabric of space-time. This warping effect allows scientists to measure the mass of the lensing object. Scientists observe these warped images. They calculate the mass needed to create them. However, the visible matter alone cannot account for the strong lensing effects observed. But there's not enough visible matter to account for the strong lensing effect. This discrepancy points to the presence of dark matter, which adds the necessary mass to explain the observations. This is another sign of dark matter's presence. It acts as an invisible scaffold, holding galaxies and clusters together, influencing their formation and evolution. It's like an invisible hand magnifying the universe around us. Dark matter remains one of the greatest mysteries in modern astrophysics, driving scientists to explore the unknown and uncover the secrets of the cosmos. Dark matter isn't just sprinkled randomly throughout the universe. It's an invisible force that plays a crucial role in the grand design of the cosmos. It's structured. It forms a cosmic web, a vast network of filaments and clumps. These filaments stretch across the universe, connecting galaxies like a spider's web. This web acts as a scaffolding, guiding the formation of galaxies and galaxy clusters. Without this structure, the universe would be a chaotic place with matter scattered randomly. Think of it like this. Imagine throwing flour into the air. The particles would float around aimlessly with no particular pattern or order. You wouldn't expect it to form perfect cookies. The flour would just settle wherever it lands, creating a mess. You need a mold, a structure to guide the process. This mold shapes the flour into something recognizable and organized. Dark matter is the universe's cookie cutter. It provides the necessary framework for galaxies to form and evolve. Without dark matter, galaxies wouldn't have formed as quickly or as abundantly as they did. The universe would lack the beautiful structures we observe today. The universe would be a very different place. It would be a vast expanse of isolated stars and gas clouds with no coherent structure. Dark matter's gravitational pull drew matter together in the early universe. This gravitational force was essential in the formation of the first stars and galaxies. These clumps then grew larger and larger, eventually forming the galaxies we see today. Over billions of years, these galaxies merged and evolved, creating the complex structures we observe in the night sky. Understanding dark matter's structure is crucial for understanding the universe's evolution. Scientists are continually studying this mysterious substance to unlock the secrets of the cosmos. It's like piecing together a giant cosmic puzzle with dark matter holding the key pieces. Each discovery brings us one step closer to understanding the true nature of our universe. Scientists are on a quest. They're hunting for dark matter particles, but it's like finding a needle in a cosmic haystack. We know dark matter interacts gravitationally, but we don't know how else it interacts. One leading candidate is the WIMP, or weakly interacting massive particle. WIMPs are hypothetical particles that interact very weakly with normal matter. Imagine a ghost drifting through a wall. That's a WIMP. Another candidate is the axion. Axions are much lighter than WIMPs, and they interact even more weakly with normal matter. Finding them is like trying to hear a whisper in a hurricane. Scientists are building incredibly sensitive detectors deep underground to shield them from cosmic rays. These detectors are searching for the faintest signs of dark matter interactions. It's like listening for a pin drop in a silent room. The search for dark matter is far from over. New telescopes and detectors are being built. These instruments will be even more sensitive. They will probe deeper into the cosmos. Scientists are also developing new theories. They're exploring alternative explanations for dark matter. Maybe it's not particles at all. Maybe it's something even stranger. Something we haven't even imagined yet. The next few decades will be exciting. We may finally uncover the true nature of dark matter. This discovery has the potential to revolutionize our understanding of physics. It could unlock some of the universe's deepest secrets. Dark matter is one of the biggest mysteries in science. It's a humbling reminder of how much we don't know about the universe. But it's also an incredible opportunity for discovery. We are constantly learning. We are pushing the boundaries of knowledge. The quest to understand dark matter is a quest to understand ourselves and our place in the cosmos. It's a journey into the unknown, a journey that will undoubtedly lead to even more profound questions and discoveries. So, the next time you look up at the night sky, remember this: what you see is just a fraction of what is out there. The universe is full of mysteries waiting to be unraveled.